make us familiar with our research training program. So, Mr. Goodness, please, you have the floor.
All right. Once again, good evening, everyone. Please, can
Even
someone just confirm you can hear me clearly?
yes, we can, sir.
Yes, you can hear you.
All right. Right. So, Mr. Jacob already spoke a lot theoretically, and I feel it's a good thing to understand basic machine learning concepts to be able to use it effectively in our research. And like he also mentioned, you are you can't afford to live now in the current dispensation without thinking of ways to involve in machine learning research. You can't be an academic person seeing the kind of the volume of data set that we have now. Data is everywhere. Data is everywhere, but the issue there is we can't see it. So it takes someone that is inquisitive and creative to be able to use those data to create insights. There are data sets, there are data sets around you that you need to gather and harness to solve community problems and to make impact. That is when your research will make impact. You can work locally. Mr. Jacob mentioned something. He said most of us in this part of the country, in this part of the world, we feel that oh, the white guys, the Western guys they have done all. But if I want to say this at this point, they don't really use local data sets. So imagine someone is doing a project on um let's say breast cancer and using the data set of an hospital or hospitals in America. That will definitely not solve Nigeria problems because the domain or the territory you carry the data from also inform the insights you will get. So there are two different things. If you want to make impact, try to look around. Try to look around. Make sure that you try to solve local problems. Yeah, for practice and for practice, personal projects, just little things here and there. But to be grounded in some of these concepts, yeah, you can make use of those um, online data sets, Kaggle, UCI, Repo, and the likes. But if you really want to solve Nigerian problems, and that's the issue we are also finding out with ChatGPT. ChatGPT might be so nice in solving international problem, but when you ask it some questions about Nigeria settings, it might not perform so well because that set that was gathered was not really from this territory. All right. So machine learning is an interesting part, an interesting field of computer science, and an interesting field on artificial intelligence. So AI is into machine learning. We have machine learning in AI. We have deep learning. We have psychological parts of machine learning of AI also. Uh, Um, so I'll quickly be showing us a walkthrough very quickly, and then we can discuss from there. I will also try to keep in some theoretical concept too. But I will say this now: if you are new to machine learning, don't be don't feel like it's a big thing. When you start it and 1 month, 2 months, 3 months, you get more exposure. And let me say this now: there is no one way to do things in machine learning or in a machine learning project. Actually, someone would say that machine learning, it's or a machine learning project will involve a lot of trial and errors. You try this, does not work. That does not mean you stop a project. You try some other things to check if it will work. At the end of the day, it's the patient person or the person that continues to try that will actually get the desired result. So there is a concept in machine learning that it's called just to buttress the point Jacob mentioned. There's a concept called no free lunch theorem in machine learning. No free lunch theorem in machine learning, and it says that there is no one. machine learning algorithm is better than others. You can't just say, oh, this machine learning algorithm is better than these other ones. Well, it depends on the problem you are trying to solve. And another thing is because a machine learning a machine learning algorithm performed well for this task does not mean that that same algorithm perform for better or best for all tasks. And that is the research part of machine learning. Some people are just one-sided, like for example in deep learning now, because we all know that Adam optimizer is one of the optimizers that yield good results. Many people now don't really try other optimizers. They just put in Adam, and everywhere is Adam. Adam now looks like the default optimizer. So, but it does not really work that way. Like in machine learning competitions now, a lot of people already dumped linear regression, they already dumped support vector machine regressor or the classifier part. They are now into um, they are now into boosting models, cat boost, gradient boosting. They just go that far. And you see some data sets that can work well with some of these little models or algorithms, and then they run up to use deep learning. And that will make me mention another theorem. There's another theorem that is called the Oscar theorem, Oscar theorem, or Oscar theorems, or something like that. That one states that the simplest explanation is better than the difficult one. So what does that mean? Is that if I have two machine learning models or algorithms that are giving me the same accuracy score, I would go for the less complex one. So what do I mean? For example, a deep learning algorithm is giving me this result, 94% accuracy, let's say ANN, and a machine learning algorithm like decision tree also give me the same accuracy score. I would not say because ANN is so large, is sophisticated, I will take it over decision tree. I might not be able to interpret ANN the way I'll be able to interpret decision trees. So decision tree will show me how the rules were formed, to show me how the trees were divided into branches. But ANN might not show me that. I may just begin to see, oh, how are the neurons formed? How did the neuron go to the next stage? What are the neurons? How did I get the final layer output? But I may not really understand how I got my results from data sets. So if I'm in that kind of situation, the Oscar theorem says that you rather go for a simpler one that can easily be explained and that can easily be understood. All right. So very quickly, I will just run us through. Let me share my screen. I will just run us through a. This is on in the medical field now. A lung cancer data set, which was gotten from the notebook was sorry, the data set now was gotten from Kaggle. Let me quickly share my screen. It will not take time because I will want us to discuss. I'll just run through the notebook in 15-20 minutes and then we'll discuss. Uh, Trying to share my screen. Okay. All right. All right. Please, can we see my screen?
Yes, yes, you can see us.
All right. Thank you. Right. So this is the test I'll be using. It's from Kaggle and it's on lung cancer. So the effectiveness of cancer prediction system helps people to know their cancer risk with low cost and also help people to take appropriate decision based on their cancer risk status. Created from the website Line Cancer Prediction System. So we have 16 attributes here, and we have 284 instances. That's 284 number of rows. And these are the features in data set. We have the gender, whether male or female. We have the age of the patient, smoking, if the person smokes or not, yes or no. Then the person has yellow fingers, anxiety, and the rest. The person takes alcohol, yes or no, coughing. Then we have lung cancer, yes or no. Like Jacob mentioned, supervised machine learning problem. And this one exactly is supervised machine learning problem. Why it is supervised? Because it's supervised because we have a target variable. We are trying to predict if a patient has lung cancer. So what this data set is doing is that we have collected data of patients with lung cancer and of patients without lung cancer. So these are previous patients, not current patients now. So it is from this data set now we'll create an application yes, application is the deployment part, which should actually be our end results. That a new customer or a new patient will just come to the system and probably input some of these features. That patient, what is your age, what is your gender, do you smoke, what, how long, how do you really get fatigued? Do you take alcohol? You will just put in some of those things, yes or no, and you will click on predict. And after clicking on predict, you should be able to see that, oh, you have lung cancer, or no, you don't have lung cancer. As simple as that. Simple. So that is what we are doing here now. So all other features in this data sets, like gender, age, to lung cancer here, is actually, sorry, to chest pain. Chest pain here is the last independent variables. Independent variables, they don't depend on any other thing. But lung cancer variable here now depends on all these other columns here. So lung cancer is our target variable, or we say our target feature. So it is a supervised learning problem because we have a target variable. We have where we are going to, we have what we are predicting, right? So that's what we'll be looking at very quickly now. Let me now open the note this. All right. Let me open the notebook. Uh, Now, please, can we see hear me?
Yes, sir.
All right, thank you. This is Jupyter Notebook using Python. This first cell here is to import my libraries. Remember, our end result is to predict cancer, lung cancer specifically. So now I'm going to import some libraries, which if you are not new to data science, you would know what most libraries are doing. You can see import panels as PD, import NumPy as MP, Seaborn as SNS. So pandas is just a data manipulation analysis library. NumPy is for mathematical activities. Seaborn is majorly for visualization. Matplotlib also for visualization, drawing charts and images. And also mix 10.plotting is also for confusion matrix or some other visualization also. And this is grid search. We are not going to use this. This is grid search CV for hyperparameter tuning. This is standard scalar for making our features or our values in the same, putting them in the same range. This was splitting in data set, train test split. This is for our evaluation metrics. Now this is for support vector machine and algorithm, classification, an algorithm, KNN, an algorithm. This is k-nearest neighbors now. Random forest also an algorithm, gradient boosting an algorithm also, and XGB classifier an algorithm. All right, so you have to import all these libraries when you want to use them. It is not so compulsory that you import them at the start, but when you are using any of these algorithms, you must import them. So you can import them, you can still import them along the line in your code cells. Now, this line here is for importing our data set. So this is the data set. It is named survey lung cancer. So df is equal to pd dot read csv, and it's also a CSV file. So pd here is gotten from our pandas here. So survey lung cancer dot csv. Now, df.head is for us to see the first 5 rows in data set. That is df.head. So, I already showed us the column that we have in the cargo website. We have gender, age, yellow, smoking, yellow fever, anxieties, 1, 2. So now they have encoded them. No, here we just saw yes, no, yes, no, yes, no. So, but it has been encoded for us in the before now. But it won't always be like this all the time. You might still have yes, no, yes, no, yes, no. I'll talk about that as we move on. Where I encoded gender and lung cancer. All right, then this is to show the number of rows and number of columns in data sets. All right, so it's showing 309 rows here and just 16 columns. There are a lot of things that I would try to say at this point, but because of our time, and I'm not sure of the kind of audience I'm speaking to, if you have some background knowledge or we are just pushing up. All right. So there is a term here we call high dimensionality. You must make sure that you have reasonable amount of columns for the number of rows that you are using. And I think there is a rule of thumb, if I'm correct now, I think it's 10 times number of rows that you have. So you must have like 10 times, is it minimum now or maximum now? So you can check that out. There is a rule for that. So that you don't have 100 rows, and then you're using 50 columns. That does not make sense. Now, df.info is to show us uh, properties of our columns in the dataset. So for gender 309, not null means that that 309 filled up values. So we don't have any empty value. So and as you can see in all these columns, we don't have empty values. In the real world, it might not look like this. And that is why ML research, people will say, make your hands dirty. Now, this is looking sweet now because it got data set online and it looks clean, looks cleaned up. But in the real world, you have to do a lot of manipulations, encode missing values, um, and the rest. But yeah, as long as you continue to work on projects, you would be exposed to most of these things. So this is data type of each column. Data type, we have objects, we have integers, and we also have we have objects and integers. We also have some other ones. We have Boolean, we have a lot of them. Now, object is referring to strings like letters, like gender now is showing M for male, F for female. That's why it's an object. But the other ones are showing 1 and 2 integers. That's integer 64. Then we also have the long answer, which is also an object here, showing yes or no. Also letters. Those are strings. So you must be able to check. Sometimes there was a data set I worked on recently. You would see that you would see that the column is age, but you are seeing objects. And in your data set, you can see that you have figures there. Now you have to now inspect that particular column and see why it is showing you object instead of integer. Probably there's a value there that instead of writing age as let's say 69 or 74 that we have here, the person just wrote mid-age, just wrote anything there. The people can be very funny in data collection. So you have to be able to check all those things. So that's what we call um, data processing and the exploration data analysis. All right. So now this cell checking for missing values, like I mentioned. So we have 0, 0, 0, 0, 0. We don't have any missing value in the data set. So the data set is looking so clean. I would like to say again, it will not always be like this. But if you gather your data set personally, you will know that you will do a lot of dirty things. And we've not gotten to the machine learning part now. This is just getting to know our data sets, which is very important. Now, we are trying to check the number of unique values in each column. Gender, we have two. Smoking, we have two. Definitely, yes or no. Most of them by just yes or no. Gender is male or female. So age is the one that we have a lot of unique values there. Now, we are checking if we have duplicates. Sometimes duplicate columns might you might need to drop them, or you might need to keep them, but you must ask yourself a question. That's why it's research. Why do we have duplicate values? Just today, I was working on a tax, and I just dropped duplicate values. It's a transaction tax where all some customers have user IDs, and they also have transaction IDs. So what that means is that the user ID to transaction ID now or let me transaction ID not user ID is one to many. That means a user ID can have multiple transactions ID. So if you and I also use some SQL code, but if you now just you're not looking at the transaction ID part, or you tend to drop transaction ID row because it's an ID, like we all do, we just try to drop ID rows. But when you drop the ID rows, you will realize that since the user ID will always be repeated, and what if the customer buys something that is the same amount, then that means that that row we definitely have duplicate rows. So that is it. Machine learning, you have to just ask yourself a lot of questions. You be able to say why, you must be able to tell us why you are carrying out a step. All right, so we have 33 here, duplicate values. Now, this is auto statistics. df.describe.c dot t just to transpose, just to make the rows columns and the columns to be the rows. Yeah. So now this is also a section where you can also get a little bit of insight from this data set. Now, we have most of them as categorical or as zeros, one and two, one and two, one and two. Yeah. So we have minimum value one, maximum value two. Definitely that's what we should have. I think I can only say a bit about this age column because that's the only numerical column. And by the way, here we describe we only work with numerical columns, but you can also work with categorical columns. When you put include is equals to all in this brackets, and you also see for that's why we cannot see gender here. Can't see non-cancer column here because it only works with numerical variables. Now, if you look at the minimum value, we have count, that's 309 like we saw earlier. We have the mean. Mean is the normal mean that we are taught in our basic schools. And that's deviation, minimum value, 25% percentile, 50% percentile, 75 percentile, and then we have maximum value. So from here, we can see that we have 87 as maximum age for the data set, 21 as the minimum value of this data set, 25% percentile just shows us that 25% of, people in our data set have age below 57 years old or are below 57 years old. That's 25%. You can see that 50% of the data sets are below 62 years old. 25% of our data sets are below 69 years old. So 50% here is also the median. So this is the middle age. So this is the middle age. All right. Let me just move on quickly. Lung cancer, we are trying to check the distribution of target variable. And don't mind these codes. I tell people it's fine that you understand the concept behind the code you are writing. And also make sure that your codes are easily interpretable, but understand what you are doing. Because now, ChatGPT will give you your codes. It will give you the right prompt. But if you don't know what you are doing, it will give you a code that will work, but will go against your logic. Let's be very careful. Now, this code here is to show us, okay, to show us the target distribution. There are other ways to do this. I just prefer to do this using a chart. There are other ways to do this. You can just do value counts, and you also get the same thing. Now, so we have 87.4% of our patients saying that they have lung cancer, and 12.6 do not have lung cancer. So this might indicate that you have more smokers, just assuming now. It's an assumption. So it's what you can also query and try to check relationship between smoking and lung cancer status. But this is not an EDA notebook properly, so we might not do a lot of EDA here. Now this is to show univariate analysis, just checking for each column. We have a bit more males. We have smoking. Smoking is okay, 2 is yes, 1 is no. All right, so you can see that we have more smokers. My assumption looks a bit right. We have more smokers. All right. Then you can just go through this. Next, we look at bivariate analysis, checking each of the columns, the relationship between each of these columns with lung cancer. So let me check smoking. I can see that for one, which are non-smokers, Um, yeah. So for two now, which are smokers, we have high number of cancer patients who are smokers. Then for non-smokers, we have lower values uh thereabout. So let's just walk around this. So this is just multi bivariate analysis. Now, by univariate is you are checking and you are analyzing each column individually. Bivariate, you are analyzing two columns, checking their relationship. Then multivariate is that you are analyzing more than two, three, yeah, three, four, there about number of columns. I think I want us to just go straight to the machine learning part. So I dropped the duplicate values here because definitely duplicate values here um, will not really make sense in our model building. Now this is encoding labels in column gender and also in lung cancer. You know, in lung cancer, we have yes, no, we have also male and female in gender. So we have to convert this to figures for our machine learning model to understand it. If machine learning models will not understand text, so you must convert them to numbers. And there are several ways to do this. What I did here, or what was done here, is manual encoding, just giving male one and female zero, or giving cancer yes one and no zero. But in the real world, um there are other methods that you can use for encoding. We have label encoding. We also have one hot uh, encoding. What label encoding will do for us is that, okay, by the way, let me quickly talk about this too. We also have something categorical variables, which are those not strings, objects, data types. We have them divided into two. We have the nominal and we also have ordinal. So what nominal categorical data of values? Nominal is male, female. There is no hierarchy. Male, female. Actually, you get that now. So no hierarchy. But for ordinal, ordinal means ordered. So for ordinal, they are ordered. So we have zero. You can see short or high and low. You can give high. Right. Somebody say something. Right. We have ordinal, something ordered like positions, first, second, third. That's ordered. So for label encoding will give each of the values in your column one, two, three. So it might start from one, two, three, and just give it as it appears in your data set. So, but the cones here now is that it might now give four an higher priority and make one look so low. And actually, one might not be low. Like, for example, saying male and female, I give male one, it will give male one and give female two. But it might inform the machine learning algorithm and say, okay, female has higher authority or priority over male, which actually in the real sense would not be does not work that way. So, but in one hot encoding we create a new column for each category in that particular column. So if you have male and female, it will create a column called gender underscore male. I'm just assuming that name, gender underscore male, and give all males one. And anywhere that it's a female, you give it zero. But then it will also open another column, gender female, give all females one, and give all males zero. But when you now have a column of categories that we have 10 categories, let's say you are working with a national data set and you have states, right? For example, in Nigeria, we have 36 states, and you want to encode that, and then you now open new, you now use one encoding, and then it now opens new columns for each of those states. It will expand data sets. So, but all this depends on data set you're writing. So for this place, we just did manual encoding, but you can also try all these steps too. You can use label encoding, use on encoding, and see how you get your result also. Now, this is correlation matrix to check for correlation between numerical variables also. I want to quickly rush now. Let me go to the machine learning part. All right. Okay. Right. Okay. Yes. Now we want to divide our data set into two, x and y. X are the independent variables, y is dependent variable. Y is dependent variable. So x will carry all features apart from lung cancer. So y is what we are predicting to carry only lung cancer. So train test plate we already imported in the first cell. That's what we use here to split our data set. So now in data splitting, you must be able to split your data set into train and test. Some people will split into train, validation, and also testing. Well, if you have large data sets that can accommodate you or that can allow you to split into validation, that's now I'm just splitting into three sets, fine. But generally, most people just do train and test. Now, if you look at this our data set, it's it has a little bit of imbalance in the distribution of the target variable. So for one, we have to 38 patients, for 038, which is a far they are so far from each other. But there are techniques that we can use. I don't think it's in this scope. It should be an introductory class. I hope I'm not already saying some kind of technical things too much. Right, let me try to reduce that. In the next 5 minutes, I should round up this session. Now, uh, we use stratify equals to y to cover up for this imbalance here. But like I mentioned, there are other ways you can do this that you would do either oversampling or undersampling. There are different techniques. You can also check that out. Now, the first model I'm going to use here now is okay, before I go there, to train data sets and testing data sets. Training data sets, what that means is that you are um, you are feeding your machine learning model now or your data sets into the model to be able to understand patterns. So it does like a form of mapping. It maps the independent variable, check to the dependent variables by checking patterns in that data set. So after it has checked those patterns, when you will now see, okay, let me now predict on new data sets that I have not seen before. So the goal about machine learning is that I am working with the data sets that I have seen before, that I know. Now I want to predict on the data set that I have not seen before, that I have not known. Now we have divided our data set now into 220 rows for training data sets. So you must give your model a lot of data, be able to train it well. Give your model a lot of data. And that is why ChatGPT can give us some kind of answers that amazes us. It is not magic. It's because it has been trained on a lot of data sets. Right. So data set was killed there. I would not like to go so much deep now, some of those concepts. I feel it's an introductory class. So let's go to the beauty now. Okay, all these codes, these are some of the things Mr. Joseph, Mr. Jacob mentioned. Now, I used a lot of machine algorithms here just for the purpose of this class. Remember Oscar theorem and no free lunch theorem. Now, this supports vector machine. Briefly or very quickly, I trained on the test set and trained on the trained set. So I predicted on the train and on the test set. Now, why do I do that? There is a concept called overfitting and underfitting that we need to also look into. What is overfitting? And then what also is underfitting? Overfitting is saying that uh, my model performs so well on my training data set, but when it sees a new data set, it performs poorly. That's overfitting. So that concept is a very important concept in machine learning and even in AI generally, overfitting and underfitting. I was talking about bias and variance. These are a bit technical concepts, but you need to understand them. So that's what I'm trying to do here by training on predicting on my train set and also predicting on my test set, just to be able to check it. So if I have accuracy on my train set as 94% like I have here, 94% like I have here, and I have accuracy on my test set at 5.7%, it looks a bit far, but it's not bad. But imagine that I have 99% here, 100% accuracy, which I have seen before in some other projects, 100% accuracy in the train set. And remember, the train set is the set that we already know. It's like it's a set that I already know. That even if by looking at it, I already know the outcome. So if it gives me 100% in my accuracy and my test set on data set that I don't know at all before, and now it's giving me 65%, then there is a problem. If you deploy that into the real world, then people that will be having type 1 errors and type 2 errors, somebody will come and predict that he has lung cancer when he does not have lung cancer. Or someone that has lung cancer and the model is the system is telling them that there is no lung cancer. So that's the point. So this is an example of a supervised machine learning algorithm, supervised vector model. So it gave us this. This is the convolution matrix it maps. So there are a lot of concepts here, and we don't really have time. This is the convolution matrix. And what convolution matrix will do for us is that convolution matrix is telling us how our model perform form of figures now. predicting the true, trying to compare the actual labels, or we call them the true labels, to the predicted label. Now, my model has predicted that this, you look at the sequence now, I don't know if I can quickly explain this convolution matrix part. We have no, we have yes, we have no, we have yes. This x part, this x side or x axis, let me just call that x axis now, the predicted label. Y axis here is the true label. What it's saying here is that the true label is 2 for no, no cancer. And the model predicted 6. Is that not an error? No, sorry. The true label here is 2. Then and the model predicted 2. So that means it's predicted correctly. So you can see no, no. Then I'm looking at the diagonal now. The model predicted yes, and the actual true label is also yes. So it got that for the 6 times. That's why we have high score here. But when your model now starts, when our true labels is predicting yes, when it's actually no. So we have 2 samples in that categories. We have yes as the true label, but the model is predicting no. I don't want us to go into that concept now. We have type 1 error, we have type 2 error. Now, the other part is the model is actually, those data points are actually no, this does not have a cancer. But the model is predicting yes. So we have 6 patients affected by that error. Now people argue which is better, type 1 error or type 2 error. Type 1 error or type 2 error. Or you see, or which is better, a person that has HIV and the doctor claims that does not have HIV. Or the person that does not have HIV and then the system claims, or the doctor claims that the person has HIV, which is better. That would be another discussion for another day. Now, logistic regression, another kind of model. So I just use a lot of them here. KNN, random forest, yeah, random forest, train and test, just to check for overfitting and underfitting. Then I also do conversion matrix for each of them. Gradient boosting model, um, naive Bayes. Then we use LDA, linear discriminant analysis. These are machine learning algorithms, decision tree, bagging, and then, okay, yeah, those are the algorithms that we used. Now, some of the results, these are just codes. These are just codes. I told us now we have AI platform that will give us codes, but understand what you are doing. That how we are doing is very important. Now, for accuracy here now, my support vector machine for the train set, I have 94.5. While for the test set, I have 85.7. So all these evaluation metrics also are very important. By the way, this is a classification problem, not a regression problem. A regression problem will ask me to predict continuous values. What do I mean by continuous values? Like predicting house prices, we have continuous values there. Predicting student scores, those are continuous values. But if I want to predict yes or no, cat or dog, pass or fail, discrete values, where we don't have middle values, those are discrete values, then it's a classification problem. And by the way, there are classification algorithms and there are also regression algorithms. There are classification evaluation metrics and there are also regression evaluation metrics. There are 2 different things. So here we are using accuracy, precision, recall, specificity, balance, accuracy, and everyone's. But there are a lot of them. We have sensitivity also. We have which one do I not use? We have ROC, AUC score. We have Cohen Kappa. We have MCC, Matthews correlation coefficient. A lot of them. Actually, Prof introduced us to some of these evaluation metrics because from Prof I learned about MCC and Cohen Kappa. Now, so this is just a breakdown of all the algorithm that we used. Checking train tests, I think the uh, best algorithm here now is random forest, which has an accuracy of 99.5 on the train sets and 92.9 on the test set. So this, the overfitting here is lower than is lower when you compare it to gradient boosting. Now gradient boosting has 99.5 also, like random forest in the train set, but you can see the distance between the test set here now to the train set is larger compared to the random forest. So if they ask me for my best accuracy, for my best model here, I would definitely go for random forest. Because if you look at balance accuracy also, we have 98.3 in random forest as the train set, and random forest for the test set is 5.4. So the overfitting is a bit lower. So I can go for random forest, but there are also explanations to each of these evaluation metrics that I want us to go and read on, depending on the kind of problem that you are solving. You don't just go into just use any of them. Now, balance accuracy will be the best for an imbalanced data set, just like our own. But remember that we have copied that effect of imbalance by using Stratify a little bit. Some of these things are there are logic and processes that with time, with enough practice and projects, you'll be able to move through. Right, these are just visualizations to check train versus test. I just like messing around with results. Yeah, I love visuals also. Now, finally, this is after concluding that random forest is the best algorithm for this project. We now carried out what we call feature importance. Now, feature importance will tell us how each feature contributes to the prediction. So now we can see that the age column contributed the most to the prediction, followed by allergic, alcohol consuming. Surprisingly, smoking did not contribute so much to our prediction. Surprisingly, but you can always go back and check because there is also what you call hypothesis testing, not hypothesis, alternate hypothesis. Let me tell you, machine learning research is with statistics. You must know statistics, you must know probability also, and then you must know a bit of mathematics because all these models that I just showed us here and I just walked through, there are enough mathematical concepts behind them. Even all these evaluation metrics, accuracy, precision, sensitivity, they are all mathematics behind them. So I'd like to stop here and welcome our or receive our questions now. Do you have any questions very quickly? Hello, can you hear me?
Yes, we can, Mr. Goodness.
All right. So do we have questions? Right. Looks as if we understood all that I've said, or we are we went more confused. Those are the two extremes now.
I think I have a question.
All right. Thank you,
Yeah.
sir.
The dimensional reduction, you made mention of it. Is it uh, what you do before you actually um, fit your data set into algorithm?
Yes, yes. You do
Okay.
that before putting it into the algorithm. There are several methods. I think we have RFE, we have recursive feature elimination. We also have PCA, principal component analysis. These are dimensionality reduction techniques that you can actually use, reduce the number of features so that it will be reasonable with the number of rows that you have. Yeah, so you do
So
that before putting it into your
which one do
machine.
you favor? Which one of
I
them?
get that, please.
Which one of them do you favor? PCA or
Uh,
okay?
I think it also depends on your data set. So
Okay.
there are also algorithms in some sense. There are also algorithms. Now, RFE actually works with a machine learning algorithm also embedded in it. So sometimes you can just feed in a base algorithm into RFE, select number of features that
Okay.
you would use. But if your features are not that much, another way to do dimensionality reduction is if the dimensionality is not so high, you can run your algorithms into your model, and after doing feature importance like we did lastly here, you can now select probably the top five and use only the top five features into the
Yeah,
model.
yeah. And I
So
think you can use the decision tree as well to do that.
that's another way. Or use decision tree, yes, because when you plot the decision tree image, you would easily see the features that are not contributing so well,
Exactly.
so much to the target variable. You will see the decision leaves and the nodes. Yeah,
Okay. Thank you.
right. You're welcome. All right. Any other question?
Please, you can also share your thoughts on the chart for further clarifications and so as to get you clarified during the course of the practical session I was taking.
Right. If we don't have any question, I think I can stop sharing here. Thank you so much, everyone, for having me this evening. And I believe that we have been having a beautiful ride in the internship. Just put your mind to it. It's actually a good one. We definitely learn a lot. Thank you.
Thank you very much, Mr. Goodness, and also Mr. Jacob for the presentation for today. Please, you can always reach out to either of them in the WhatsApp group chat for more clarity and for guidance and mentoring. Mr. Goodness and Mr. Jacob are both alumni of the previous research training program with Ada Global Academy. So they have been in the same position or in the same state where you are now, and they can always provide immense mentoring experience to ease and to ensure a smooth ride in your research training program. So thank you for coming in today. I believe we have a fundamental understanding on the practical application of machine learning in any domain and any research topic we choose. And I hope we gain more experience as we progress in our data science journey and in our research training program in particular. Yeah, so I think we'll be stopping the meeting now. If there are any questions, please feel free to reach out to any of us on the group chat and we'll be more than willing to assist you. Thank you and have a good day.